Chapter 7, Lesson 3, we are going to look at examples 1 through 4, is on logs and log functions. Something that you need to be familiar with is knowing how to change something from log form to exponential form. So the example of that is right here. Your base number that is with your log is becoming the base of your exponent. The 27 that is right here is moving to what it's equal to, and then the y that it's originally equal to is becoming your exponent. So it's really just a matter of rearranging things. Whenever you rearrange things, the log drops, part of which is why you're changing from log form to exponential, is I really want the log part to actually go away. So we will look at examples of what that actually looks like. In examples 1 through 3, 4 we'll use it a little bit, but it's more so graphic. So looking at example 1, it tells you to write log with a subscript of 3, 9 equals 2 in exponential form. So you are not solving anything in this question, you're just rewriting it in exponential form. So your base of 3 that is right here is going to become the base of your exponent. The little, or the 2 that is right here is going to become your exponent, and then the 9 is going to move over to this side. So it should make sense when you're rearranging it that you know that 3 squared is equal to 9, like the two sides should balance out. So to change it to exponential form, that's all you're doing. In turn, you kind of did solve it, but you're not actually solving for anything, you're just changing the format of it. So for part B, again, what that would look like is your subscript of 10 is becoming your base, your negative 2 is becoming your exponent, and then this is equal to 1 over 100. So 10 squared will give you 100. Because it's negative, I have to move it to the denominator to ultimately make my exponent positive, since I can't have a negative exponent. So your answer would look like this. So that is it for example 1. Example 2 is then doing the opposite. So example 2 is changing it from exponential form to logarithmic form, so working backwards. So your base within the exponent 5 is going to become your subscript. The 125 is going to move back over here, and then your exponent of 3 is going to move to the other side of the equal sign. So I'm kind of undoing what I just did in example 1. So my answer to part A is going to look like this. So again, not solving anything, just rewriting it from one format to the other. So then for B, it says to write 27 to the 1/3 power equals 3 in logarithmic form. So adding in my log, my 27 is going to become my subscript. I would move my 3 over, and it is equal to 1/3. So example 1 and 2 are kind of opposite of each other. It's just changing from one format to another. You're not really solving anything, just changing what the actual setup looks like. This will be important whenever you go to solve in this lesson, but also in lesson 4 whenever you get into equations with this and you actually do have to rearrange things in order to be able to solve for a variable. So looking at example 3 is now actually asking you to solve this or evaluate. So you need to figure out what it's equal to. And I know there's not an equal sign for this question. You can add an equal sign in a variable y, x, it doesn't matter, in order to know where stuff would go when you change it from log form to exponential form. So if anything ever asks you to evaluate, you're still changing it from log to exponential form and then solving. So in changing it to exponential form, the subscript of 3 is going to become my base number. The equal to y part that we kind of added in becomes my actual exponent, and then it would be equal to 243. So what this question is actually asking you is 3 to what power is equal to 243 is really what you're trying to find. So it's easier to think that through when you first change it to exponential form and then know what you're actually looking for. So you could plug that into your calculator. You can figure out 3 times 3 times 3 multiple times until you figure out what y is. Whenever you solve this, you would get that y is equal to 5, or whatever variable you want to use. So again, you're really just figuring out 3 to what power gives you 243. So examples 1, 2, and 3 are all similar to each other in terms of changing from log form to exponential form, or vice versa, and then kind of using that to solve. Example 4 is going to get into graphing stuff. So examples 4, 5, and 6 are all actually graphing. Example 6 is a word problem, but examples 4 and 5 are graphing. Before we get into the graphing, this chart that you have, or key concept that you have in your notes, is going to be something that is important for you to look at, and I will refer back to it as we are looking at example 4. Example 5 doesn't necessarily use this a whole ton, but this is really for example 4. The biggest thing to pay attention to is this and this. So what this is saying is, if your base of your log, or the subscript that is with your log, is greater than 1, your graph is going to look like this. There are specific ordered pairs that go with it, and you're really just plugging in your b value into this ordered pair and this ordered pair. Then if your exponent, or your, not exponent, if your subscript is between 0 and 1, so if it's greater than 0 but less than 1, this is how your graph would look as far as the shape, and then these are the points that you would be using. So you'll notice that 1, 0 is the same on both of them. B1 is the same on both of them, and then 1/2, -1 is the same on both of them. It's really just going to look different because the b value is going to change. So if your b value is greater than 1, it should make sense to you that your graph is going up. If it's less than 1, or kind of, but greater than 0, it's going to be a graph that is decreasing or reflected down. So what that looks like in these questions is, there is an example for part A and part B. There's one of each kind, so we're going to look at each kind. So for this first one, this says to graph the function f of x equals log 3x. So 3 is the number that I'm using. That's my b value. So 3 is greater than 1. So why that's important is that tells me this is the type of graph that I'm using for 4a. So the ordered pairs from that, I'm going to pull straight from that example, which are 1/2, or 1 over b, -1, 1, 0, and then b1. And then you're just filling in your b value. So this would become 1/3 -1. This is always going to be 1, 0, and then this will be 3, 1. So these are the points that I am using to make my graph. So when I do that, 1/3 -1, and it's kind of hard to show that, but it would be in this general area. 1, 0 would be here, and then 3, 1 is I'm moving over 3 and going up 1. So my graph will look somewhat like this. So because it's greater than 1, I have a positive graph, meaning it's starting negative, going from this direction and then moving up. So that's all you are doing for these questions. So then example for part B is the other one. So looking at my B value is 1/4. So again, going back to this chart, 1/4 would fall between 0 and 1. So this is what I am using for 4B. So for 4B, the reason I'm using it is 0 is greater than 1/4, but is less than 1, so it fits into that second graph category. So the points for that, again, are 1 over B, 1, 1, 0, and then B, -1. So the only difference is, actually there is no difference, so sorry. Okay, so you're plugging in your 1/4 to this. So for the 1, 0, it's just gonna stay 1, 0, there's no B in this. As far as your 1/4, this, I would have 1 over 4, because I have a fraction divided by a fraction. I'm really going to end up multiplying, and this would become 4 -1. Or sorry, 4 -1. I mixed these two up. So this is a -1, and this is a positive 1. I wrote them backwards. So this is, again, original points, same from the last one. So 1/2 -1, 1, 0, and then B +1. So your B value is 1/4. So when I plug that in, I would have 1 over 1/4. So I'm going to end up multiplying by 4, which really just gives me 4 and then -1. Then this ordered pair down here would just plug in 1/4 and then +1. So these are the 3 ordered pairs that I am using to graph. So 4 -1 means I'm moving over 4 and going down 1. 1, 0 is the same place the last one was. And then 1/4 1 would be in this general area. And your graph will make the same type of shape because it is 1/4. So because it's between that 0 and 1, I would have a decreasing graph where it is going down. Okay. So same points that you're plugging into for A and B. So like these are kind of your points that you'll always use on this. So it really, not that it doesn't matter what your B value is, but your B value should help you know that if it's greater than 1, it's going to be an increasing graph. And if it's between 0 and 1, it's going to be a decreasing graph. Okay, so that is it for examples 1 through 4. We will look at 5 and 6 tomorrow.